Hello everyone. Welcome to this presentation on azeotropic distillation. In this presentation, we want to learn about azeotropic distillation, why it is needed, in what situations azeotropic distillation is applicable because simple distillation can't be applied, and also explain how the process goes about. The following are the important points discussed in this presentation. What are azeotropes? Why simple distillation can't separate azeotropes? Azeotropic distillation. Entraîner. The process. Applications. An azeotrope is a mixture of two or more liquids that, when boiled, vaporizes at a constant boiling point and maintains the same composition in both the liquid and vapor phases. This means that the relative proportions of the components in the mixture remain unchanged during the distillation process. In simpler terms, an azeotrope behaves like a single substance during boiling because the components in the mixture distill together in the same proportions, preventing their separation by simple distillation. Key characteristics of an azeotrope. Constant boiling point. An azeotrope has a specific boiling point, unlike other mixtures where the boiling point changes as the ratio of components changes during distillation. Same composition in vapor and liquid. The ratio of the components in the vapor is the same as in the liquid, meaning no matter how much you distill, you can't separate the components by simple distillation. Example. Classic example of an azeotrope is the mixture of water and ethanol. At a specific ratio of about 95.6% ethanol and 4.4% water, the mixture forms an azeotrope. Even if you boil this mixture and condense the vapor, the liquid will still have the same ratio of ethanol and water, 95.6% ethanol, 4.4% water. The boiling point of this azeotrope is around 78.2 degrees Celsius, and you cannot distill it further to increase the concentration of ethanol without using special techniques. Simple distillation cannot be used to separate azeotropes because of the way they behave during boiling. Here's why. Constant boiling point. When an azeotrope is heated, it boils at a constant temperature. Unlike regular mixtures, where the boiling point changes as the composition shifts, the azeotrope behaves as though it were a single substance, even though it's a mixture. This means that during simple distillation, the ratio of components in the liquid and vapor stays the same, and the composition doesn't change as the mixture vaporizes. Same composition in vapor and liquid. In an azeotrope, the vapor that forms has the same composition as the liquid. Normally, in distillation, a component with a lower boiling point, like ethanol in a water-ethanol mixture, will vaporize first and, as it distills, the remaining mixture becomes richer in the higher boiling component. However, in the case of an azeotrope, this separation does not occur because the azeotrope has a fixed composition and both phases, liquid and vapor, have the same proportion of components.
The process of azeotropic distillation is a technique designed to break the fixed composition of an azeotrope, allowing for the separation of its components. Here's a breakdown of the process. 1. Preparation of the mixture. You start with a liquid mixture that forms an azeotrope, typically two or more liquids that cannot be separated by simple distillation due to their constant boiling point and identical composition in both liquid and vapor phases. An entrainer is a substance that is added to a liquid mixture during the process of azeotropic distillation to help break an azeotrope. The entrainer alters the vapor-liquid equilibrium of the mixture, usually by forming a new azeotrope with one of the components in the original mixture. This new azeotrope has a different boiling point, allowing the components to be separated by distillation. In simpler terms, the entrainer acts as a helper that changes the physical properties of the mixture, making it possible to separate the components that otherwise could not be separated due to their identical boiling points, in the case of an azeotrope. The entrainer often has a different boiling point from the components it interacts with, which facilitates the separation during the distillation process. Example of an entrainer. Benzene is often used as an entrainer when trying to separate water and ethanol. Water and ethanol form an azeotrope that can't be broken by simple distillation, but adding benzene forms a new azeotrope with ethanol, which has a different boiling point. This allows for ethanol to be separated from water more effectively. After the distillation, the entrainer can usually be removed by further distillation since it has a different boiling point than the components it helped separate. To break the azeotrope, you add an entrainer, a third substance, which is chosen based on its ability to form a new azeotrope with one of the components in the original mixture. The entrainer changes the vapor composition and often shifts the boiling point of the azeotrope. The entrainer typically has a much different boiling point than either of the components in the original azeotrope, which is crucial for the separation process. 3. Formation of a new azeotrope. Once the entrainer is added, it forms a new azeotrope with one of the components of the original mixture. This new azeotrope typically has a different boiling point than the original azeotrope, so it can now be distilled. 4. Distillation of the new azeotrope. The mixture is then heated, and the new azeotrope, containing the entrainer and the component it is paired with, will vaporize first. The temperature of this azeotrope will be different from the original azeotrope's boiling point. The vapor is then condensed back into liquid and collected separately. This step effectively separates one of the components from the original mixture. 5. Separation of the entrainer. After distillation, you will often need to remove the entrainer from the collected distillate. This is typically done by further distillation, where the entrainer is separated based on its distinct boiling point, leaving behind the purified components from the original mixture. 6. Final separation. After the entrainer is removed, the remaining liquid should have a higher purity of the original component. If needed, the process can be repeated to further purify the separated components. Example: water-ethanol azeotrope. For the water-ethanol azeotrope, even though ethanol has a lower boiling point than water, 78.37 degrees Celsius versus 100 degrees Celsius, when you try to distill a mixture of ethanol and water, you'll get a vapor with the same composition, about 95.6% ethanol and 4.4% water, no matter how much you distill. This is the key reason why simple distillation doesn't work. The components don't separate out in the way they normally would. In summary, simple distillation relies on differences in boiling points to separate components. Azeotropes, however, boil at a constant temperature